Hi everyone, my name is Janaya, and today I will be presenting my Module 3 discussion lab simulation. For this lab, I chose to do the broken pencil experiment. The reason why I chose this particular experiment is because I am very familiar with it and it just goes along with my job. I'm always explaining light refraction, so that also has something to do with the broken pencil experiment. So, have you guys ever seen something that looked broken, but it wasn't? Today, we're going to be scientists and we're going to experience that, but it may surprise you or shock you with what will happen in this experiment. So, today we're going to be making a prediction, okay? I want you guys to get a piece of paper or a sticky note, and we're going to just make a prediction. So, what do you think will happen when I put a pencil in some water? Mind you, we are going to be using a clear glass and we're going to fill it up with some water. The water is not going to be filled up to the rim. It's going to be about halfway, just so we can show that a pencil can look broken. Just for this particular experiment. Do you think that things will look the same? If so, why is that? Do you think things will kind of look a little different, kind of look a little funny? Do you think it will make things look again different? If so, why is that? Do you think that the pencil will look broken? I want you guys to pause and think about this for about 10 to 15 seconds. All right. Now we are going to test this out. Step one. First, you're going to get a glass of water, a glass cup, and you are going to put water inside of your cup. But we're going to make sure that our cup is not filled to the rim. We're just going to make sure that there's enough to where we can see the pencil inside the cup. So you're also going to put water inside of it again, and you want to get a pencil. Now, you can use a pen, a pencil, a marker, colored pencil, whatever you desire. Okay, so we are going to place the pencil inside of the water. That's the first thing we're going to do. But before we get started, do you guys notice how, like there's nothing inside of the cup of water? But when we look at our pencil, do you guys see how the pencil is straight? It's not bending. It doesn't have like a curve to it. It's just a straight lead pencil, okay? So I want you guys again to look very closely to see what happens to this pencil when we put it inside of the cup of water, okay? All right, let's get started. So I'm going to place the pencil inside of the cup, just like this. I'm going to try to, okay. I'm going to move the cup around so you guys can see. There's kind of a blur, so I'm going to try to turn this off for a second. Okay, now you guys can kind of see it a little better. Do you notice anything about the pencil? How it looks? If it kind of looks a little funny? Or does it look the same? Okay, I'm going to put that to the side so we can continue. So what did you guys see? I'm going to give you a couple seconds to answer. Did the pencil look broken? Did it look the same? If I take this pencil out of the cup of water, does the pencil look how it looks when I place it in the water? What do you guys think? Okay, I'm going to take it out. Does the pencil look broken? Okay, so the pencil, it does kind of look a little broken. Um, but it's not, the pencil's not really broken, but it appears or looks like it is broken. Why do you think this happens? Why do you think the pencil looks like it's broken in our glass of water? Why do you think that is? I'm very curious to know. All right, so the reason why the pencil kind of looks broken is all because of refraction. Okay, so refraction is when light bends and when it moves from water to air, just making the pencil look broken. So, what causes the bending is refraction. Okay, it's refraction. What causes the bending? Refraction. Okay, so on the right hand side, it's just a better picture of this experiment. Okay, so so you guys can notice in the picture, the pencil looks like it's broken. It's just kind of like our eyes are playing tricks on us. It's making us believe that the pencil is broken, but we know that the pencil isn't actually broken. If you have any questions, please let me know at any given point. At any given point, please let me know. So, what is a discrepant event? A discrepant event is something that surprises us or kind of shocks us. It's when we see something happening that doesn't match what we thought would happen. This makes us curious and makes us want to learn even more. So, in science, it's very good to be curious. So, just like our broken pencil experiment, we thought the pencil would look normal in the water, but it looked broken. That was kind of surprising, right? But again, we know that it wasn't really broken. Our eyes, again, were just playing tricks on us just because of the way that the light moves. That's what makes science fun when we discover new and exciting things. Why do we use discrepant events in science? Discrepant events help students ask questions and think like scientists, observe things in a new way, and it also kind of makes things, again, fun and exciting. Science is all about asking why something happens. I also feel as though with science is very important, that your students are asking those questions, being engaged within the lesson. Science can be really fun. Again, it can be really fun and exciting. Why are discrepant events used in elementary? They make students curious and excited to learn. They encourage students to ask questions and, again, think like scientists. They help students remember science concepts in a fun way. For example, in our experiment, the pencil looked broken, but it wasn't. This helped us learn about light and how it bends in water. The surprise made us want to know even more. Now we're going to connect our standard to our science. The specific standard that I chose was S1P1: obtain, evaluate, and communicate information to investigate light and sound. Our experiment helps us understand how light is important for seeing objects. The pencil looked broken because light bent. It was kind of like bending when it moved from water to air. This connects to our science standard S1P1A, which says we should use observations to explain how light helps us see. We need light to see objects clearly. Light can bend and change how things look, again, just like the pencil. Scientists study light to understand the world. So here is our wrap up and reflection. I would love for you guys to get a sheet of paper for this reflection. First question is, what did we learn today? I'm going to give you guys a couple of seconds. Did the experiment surprise you in any way? And how would you explain refraction to a friend? How would you explain this experiment to a friend? I would love for you guys to try this experiment at home and share with everyone else, kind of see like what you see. So, you guys have a mission, okay? This is your challenge. I want you guys to find another example of refraction in real life. I want you guys to look around your home or even outside. Can you find something that looks different because of light? If so, what is it? I hope you guys enjoyed my presentation. And if you have any questions, comments, or concerns, I'm more than welcome to answer them.